Let us look at proposition number 31 of book 6 of Euclid's Elements. The proposition says, in right-angled triangles, the figure on the side opposite the right angle equals the sum of the similar and similarly described figure on the sides containing the right angle. So basically, what the proposition is saying is that if we describe a figure on BC, it would be equal to the sum of the figures described on AB and AC. So let's create those figures, construct those figures. Let's say we have figure R on BC. Let's construct figure P on AB, and let's construct figure Q on AC. So the proposition says R is equal to P plus Q. Now, somewhat similar thing that we have seen previously is square on BC is equal to the sum of the squares on AB and AC, which is our Pythagoras theorem. Here it is being generalized to other figures. How do we know that these are actually similar figures? I have constructed it in such a way that they are similar. Now, how do we quickly figure out that they are similar? Let's position them. Once we position them and we draw the diagonal, then all these points would also lie on the diameter or the diagonal. So P, Q, and R are all similar to each other. Let's see how we can go about proving this. So first thing we do is construct a perpendicular from A to BC. Now we know that triangle ABC is a right angle triangle with the right angle being at A. So AD is perpendicular to BC, and based on one of our previous propositions, we know that triangle ADB is similar to triangle ADC, and both of them are similar to triangle ABC, which means that if we look at triangle ADB and ABC, we know BC is to AB as AB is to BD. So here BC is to AB is equal to AB is to BD. So which means we have three segments that are proportional, which tells us that the parallelogram R is to parallelogram P is equal to BC is to BD, again based on one of our previous propositions. Similarly, we can say parallelogram R is to parallelogram Q as BC is to AC. Again, remember, we can say BC is to BD plus CD is equal to figure R is to figure P plus figure Q. But we know BD plus CD is BC. BD plus DC is equal to BC. So which means we have the ratio on the left hand side becomes BC is to BC. The ratio is 1. That means the ratio on this side will also be 1. And that is possible only when figure R is equal to figure P plus figure Q. So we have shown that figure R, the figure constructed on BC, which is opposite the right angle, is equal to the sum of the figures constructed on the other two sides of the triangle. Naturally, the question arises, can it be some other figure? Yes, it could be any kind of figure. It could be a pentagon with one of its sides being equal to AC, AB, and BC. So instead of having parallelograms, we could have pentagons, we could have hexagons. In that case, also the statement would be true, provided all those figures are again similar to each other. So that is proposition 31 of book 6 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.